Hello viewers, welcome to my channel. We are discussing chapter number 10 of 10th standard science, right? In last video, I introduced concept of reflection in spherical mirror and some basic of reflection. Today I am going to introduce image formation in concave mirror, right? You know that there are two type of mirrors, right? Concave and convex. So in this video I just going to introduce concave mirror only. Image formation by spherical mirror. So for that we need minimum two rays, right, to format a image. So let's start with the first ray. A ray is passing through the C, center of curvature. So this is the ray, incidence ray, which passing through the center of curvature, right? Now the reflected ray is also in the same direction, right? You can see that it is in same direction, means it is opposite the incident ray, but it is the same direction. Now why this happen? So you know that normal of mirror are passing through the C, so your angle between incident ray and normal is 0, right? So you know that angle of incidence and angle of reflection are same, so your angle of reflection is also same, right? So that's why it is in same direction. Now let's take another ray, okay, a ray which parallel to the principal axis. So you can see that here four rays are there, right, and it is parallel to principal axis. Why it's happen? When your light source is at infinite distance, at that time the rays become parallel, right? So a reflected rays, this is your normal right here. So ray is always, reflected rays is always met at one point at the principal axis. This is called point F, which is denoted by F and which is called a focus point. A distance between F and P is called focal length, right? And it always half than a distance between C and P, which is your radius of sphere, right? So if your focal length FP is F, then CP is 2F, right? So this is the two ray. One ray is passing through the center of curvature and parallel to principal axis. This both ray we are going to use for the image formation. A parallel ray to the principal axis is also called a paraaxial ray, right? So let's start another image formation. Okay, we have a concave mirror, right? A principal axis with 3 points, center of curvature, focus point and pole P, right? Now this is your object is at the infinite distance, right? So you know that if your object is at infinite, okay, so your ray is always parallel, right? You can take an example of sun, right? When a sun is the almost infinite distance from the earth, right? So when rays is coming from the sun, okay, it's almost a parallel to each other, right? So this is the ray which parallel to principal axis, okay. So you know that it is always reflected at focus point, right? So here your image will be formed, right? Now what is the nature of the image and what is the size of the image? Let's see that. So where is your position of object? At infinity, right? Because it is the come from the infinity distance, right? Position of image is at the focus point, right? Size of the image is highly diminished, means it is very smallest. And real and inverted. Inverted means it is downside of the principal axis, and real means it is the left side of the your mirror, right? It means it is left side of the mirror, means it is reflected in the same direction, right? You know that you see the example of mirror, at that time some image will be formed and right side of the image, right? And that is called as a virtual image, right? We see that in few minutes. Now what is the next position of object? So this is again a same. So now your next position of object is beyond the C, right? It is beyond C. So now let's take one ray which parallel to principal axis, right? Its reflect to focus is passing through the focus, right? Reflected ray. Now one ray is passing through the C and it's again to return in same direction. So your image will be formed here, right? So this is the point where this point is coming. What about this point? A down point. So again you passing one ray is parallel to principal axis, again it meet here, right? Again it's passed through the center and it is again meted here. So this point is same as this point. So this is your image which you can see in red color, right? So now what is the nature of the image? Let's see that. So position is beyond the C, right? So your image is always between C and F. Your always image is image is form is between C and F, and your object is beyond C. It is diminished, it is small, right? It is real and inverted. You can see that this is the arrow is upper side and here arrow is downside, right? So it is inverted, right? And it is real because it is left side of the mirror, concave mirror, right? Now next position is at C. So this is the image which at C. So let's take a parallel line passing through the focus. One line is passing through the center, right? But if this is the center, then it's never get reflected, right? So that's why one ray is passing through the focus. You know that if a ray is parallel to the principal axis, then it reflected ray will passing through the focus. Then if the incident ray is passing through the focus, then always it is the parallel to the principal axis. So here it is parallel to principal axis. You can see that this is the reflected ray, right? So your image is formed here. So you see that, okay? This is your image. So what is the nature of image? So position of object is at C, right? Position of image is at C, right? Same size and it is real and inverted. You can see that. Here I take two rays, which one ray is parallel to principal axis and second one is passing through the focus. Okay? I don't use C because it's never met. That's why. Next position is between C and F. Right? You can see that this is the object which between C and F. This is the parallel ray, right? Passing through the focus, and this is the point which passing through the C. So you see that this is meeting here, right? So here your image will be formed, right? You can see that. So now what is the nature of the image? So position of object is between C and F. So here your image is object is between C and F. Your image is beyond C. You can see that it is beyond C. Size of the image is enlarged. Okay, you can see that it is bigger one. and it is real and inverted, right? Next is at F, right? Your image object is at F position. Now take a ray passing through the F, right? See, now you can see that this both are line is parallel. So you know that if line is parallel, it can be never met. So here no image will form, right? And it's formed, then it's very large. So position of object is F, at F it is at infinity. Position of image is at infinity. Size of the image is highly enlarged, right? And nature is, you know that it is real because left side of the mirror and inverted, right? You do not take a projection from this because it is also parallel, right? So there is a no possibilities to form the image, right? Now next object is between F and P, right? This object is between F and P. Let's take a parallel ray passing through the F, okay, a ray which passing through the center. Now you can see that these reflected ray are away from each other, right? It's never going to match. Now we take a projection to right side of the mirror, so like this, right? We take a projection, so we just nothing take a projection inside the mirror. So how it possible? Because if you take your eye here and you see this image, okay, you see that this point is inside the mirror, so that's why we take a projection inside the mirror, right? If you take your eye here, then right, you can see that. So this is your image. Now here you can see the image, right? Now let's take check of the information of the image. Position of object between F and P, right? Now position of image is behind the mirror, you can see that, right? Size of the image, you can see that it is enlarged, right? And nature of the image, now you are going to see that it is virtual because it is right side of the mirror or inside the behind the mirror or inside the mirror, as well as this is a erected, means this is the upper side of the principal axis. Till what happened, your all the images are from below the principal axis, but this is the upper side or top of the principal axis, so that's why it's called as a erected, right? So these all are the posts of the images, right? Image formation. So this is a table which given in your book, table 10.3, okay? You can see that, and you just do not try to remember, okay? Just try to understand it. It easily remembered by you, right? If you know the what is the position of object and you just draw a ray diagrams, you can directly go with the all this type of objects and table, right? Thank you.